The missile knows where it is at all times. It knows this because it knows where it isn't. By subtracting where it is from where it isn't, or where it isn't from where it is, whichever is greater, it obtains a difference or deviation. The guidance subsystem uses deviations to generate corrective commands to drive the missile from a position where it is to a position where it isn't, and arriving at a position where it wasn't, it now is. Consequently, the position where it is now the position that it wasn't, and it follows that the position that it was is now the position that it isn't. In the event that the position that it is in is not the position that it wasn't, the system has acquired a variation. The variation being the difference between where the missile is and where it wasn't. If variation is considered to be a significant factor, it too may be corrected by the GEA. However, the missile must also know where it was. The missile guidance computer scenario works as follows. Because a variation has modified some of the information the missile has obtained, it is not sure just where it is. However, it is sure where it isn't, within reason, and it knows where it was. It now subtracts where it should be from where it wasn't, or vice versa. And by differentiating this from the algebraic sum of where it shouldn't be and where it was, it is able to obtain the deviation and its variation, which is called error.
For a number of years now, work has been proceeding in order to bring perfection to the crudely conceived idea of a transmission that would not only supply inverse reactive current for use in unilateral phase detractors, but would also be capable of automatically synchronizing cardinal grammeters. Such an instrument is the turbo encabulator. Now, basically, the only new principle involved is that instead of power being generated by the relative motion of conductors and fluxes, it is produced by the modial interaction of magneto-reluctance and capacitive diractance. The original machine had a base plate of prefamulated amulite surmounted by a malleable logarithmic casing in such a way that the two spurving bearings were in a direct line with a panametric fan. The latter consisted simply of 6 hydrocoptic Marsal vanes so fitted to the ambifacient lunar wane shaft that side fumbling was effectively prevented. The main winding was of the normal Lotus O-delta type placed in panendermic semi-boloid slots of the stator, every 7th conductor being connected by a non-reversible tremie pipe to the differential girdle spring on the up end of the Grammys. The turbo encabulator has now reached a high level of development, and it's being successfully used in the operation of Nofertronians. Moreover, whenever a fluorescent score motion is required, it may also be employed in conjunction with a drawn reciprocation dingle arm to reduce sinusoidal repleneration. It's not cheap, but I'm sure the government will buy it.
Okay, now that you're up to speed on the terminology of this space news stream and Space and Rocket Review stream, we can start. Welcome to the Space and Rocket Review. I am EJ, your host, the Space and Rocket Review. You two girls, tell your friends. Space and Rocket Review, you in the hat. Anyway, we have to finish up the space news links that were from yesterday, and we got a lot of them today. So, yep, already got that, Vargon. I got that. I got that. Got that. Okay. This time with power. Yep. I have that already, Phil. Yep. You guys got some links. Just want to make sure. Oh, I don't have that one. I don't know where I'm going to weasel that one in, Coder, but we'll, Okay, I'm trying to keep all the Starship stuff and all the SpaceX stuff kind of together. So let's go over there. Stoke, move that way. Put that with Blorgen. Okay. All right. We'll start off. You need different thumbnails on YouTube gaming versus space news. Oh, crap. I forgot to change the thumb. Maybe I can change it now. Maybe it'll work better if we change it now. What should we change it to? Give me 1 second. There we go. Nice. A thumb? Okay. Astroscale is doing ISAM things. Yeah, Rocket, I don't have that yet. All right, but we're going to start off today with a video. I'm going to go through this stuff pretty quick, so let's send it. This is coming from SpinLaunch. This is the first I've heard from anything SpinLaunch in almost 5 years, to be honest with you. They've been very quiet for a little while, so let's see what they're up to. Introducing the world's first ruggedized satellite. Let's see.
We first heard about SpinLaunch as everybody else did, which is the ridiculous YouTube videos or the sort of like, oh, these people are doing this down in California, and many eyebrows were raised, right? Because we looked at that and we said, this is ridiculous. We're building a 1U CubeSat. The worst thing that we could do is build it for 10,000 Gs. We can barely make it for random vibe, right?
Because this launch environment is unique, I think it's really helpful when we can pave the way and show what that kind of development actually looks like. We have spun a 1U satellite with all of the key pieces that you'd hope to see in a full satellite spin test, and it works. So we didn't want to just spin any box that we call a satellite. We wanted to spin a real satellite.
The Portland State Aerospace Society is a student group, interdisciplinary student group here at Portland State University. So ORSAT came from wanting to build a CubeSat, a small nanosatellite, that we wanted to be open source. So right now we've got a 1U in space, which is ORSAT 0, it's Oregon's first satellite, and it's a technology demonstrator for the ORSAT bus.
But I said 0.
So when we first engaged with ORSAT, we were talking with their faculty leader, talking through the idea of what we were trying to do here, building a satellite that you could spin up to 10,000 Gs and still operate the same way as you would any other satellite afterwards. We asked ORSAT, what would it take to knock your socks off that this satellite could survive 10,000 Gs?
If we could do a launch with you guys, right, what would we have to have? Well, we have to see the solar cells not fall off, right? And not break, obviously. We'd have to see the battery pack, which is the heaviest component we've got, not, turn into a pile of dust or worse, flaming pile of dust. And the chips not fall off.
ORSAT has a battery pack that they designed that is open source, so we were able to take that design and analyze it ourselves. Their battery pack is standard battery pack construction in the satellite industry. What we wanted to see about that battery pack, though, is can it survive 10,000 Gs by itself with no modifications whatsoever?
We as a group didn't think they were going to go past 100 Gs. And I think you said they reached 7,000 Gs, and we were shocked.
For a lot of components, they're already pretty close to being G-hardened. The university team was able to design a battery pack that survived 7,600 Gs with no modifications by accident. We made a few key changes to the battery pack, including aligning the long axis of the battery cells with the G-vector, so they're kind of like a pillar or a column under compression. We also took those battery cells and put them in a carbon fiber tube. This tube construction is something that NASA already does for fire suppression on some of their battery packs. We also moved the battery cells down so that they're resting on the floor of the satellite. And then we added just a little bit of glue in behind the cells and on the electronics. When we made those small modifications, we then spun the modified battery up to 10,000 Gs and showed that it survived, leveraging almost the exact same design as ORSAT's with those key changes. The solar cells that we used are a little bit different than ORSAT's. They're just a little bit bigger, but otherwise they're exactly the same. For the frame, we took ORSAT's open source design, and we did our own analysis on it first before we manufactured it and built it to see if it would survive 10,000 Gs. And we found that it was pretty close as is.
This still looks very similar, right? We still have the 4 rails. They're still spaced the same way apart. I especially like if you look at the sidewalls here, if we turn these sideways, that it's the same pattern. We're not adding thickness or ribs or anything like that. We wanted to keep the web the same.
The C3V5, C3 stands for Command, Communications, and Control, onboard computer, flew on ORSAT 0, and that's what you guys spun.
We took their onboard computer and added just a little bit of glue, otherwise it was completely unmodified. There are a few key lessons that we've learned over the years of G-hardening and using the accelerator behind me to do all of this G-hardening testing. On a lot of electronics, they survive a really high G level unmodified, but for some of those bigger components like large capacitors or connectors, a little bit of glue goes a long way and will actually allow it to survive 10,000 Gs. I think there's a huge milestone there where you put all of these key satellite subsystems together into a 1U satellite and showing that all of those together can function.
Right there, you'd be having a bad day. Right there, you'd be dead. Well, yeah, no, you'd be way dead.
Could we plug it in and see if it still clicks and beeps?
Yeah.
All right, cool.
So that's a good sign. So that's the watchdog timer coming on, that's the power supply going on, and that's the radio power coming on. That's the CAN bus.
Hey, there you go. So that means that we're getting CAN messages?
Yep, we're getting CAN messages.
Awesome.
Which is good. And I've got my serial port here, and I'm talking to it, and I can actually go ahead and send a beacon. And you can see the little LED flash of the beacon. So it's great.
Yeah, so that means that RF
RF survived, yeah. Yeah, at this point, it's talking to the battery pack. The battery pack is now on. It got turned on by the C3, so it saw it and said, oh, there's the battery pack, let me turn it on.
Nice.
And now we're operating. I'm gonna say it flat out, we're shocked. We had no idea that you could actually spin this up to 10,000 Gs and it would survive. We were surprised by the small amount of modifications you needed to make. We were expecting to have a flood-filled epoxy brick, right? And instead, it was our boards. Yes, there's epoxy on some of the larger components, and yes, you have to put them in the right, way and things like that. But that was a surprisingly engineerable, if that's a word, kind of solution or change to the system. What I am convinced now, which I was not convinced before, is that we can build something without a lot of work and without a lot of effort that could survive the 10,000 Gs.
Spinning the 1U has been a part of the development plan from the very beginning, right? You start small and you incrementally improve the TRL level or the milestone maturity that we're at.
Technology readiness level.
We weren't surprised that the 1U survived because we've built up this engineering intuition over time and we have a good sense of what succeeds and what is susceptible to failure. It's really exciting to be able to say that we've spun a satellite up to 10,000 Gs.
I guess SpinLaunch is still around. I hadn't heard anything about that ever. So SpinLaunch is a company that's trying to basically make their first stage into a hypersonic merry-go-round. Yeah, that's a good way to explain that, sure. So basically what they're going to do is they're going to take second stage, right? And then their payload, encapsulate it in a fairing, a missile-shaped fairing, I should say. And they're going to spin that around really fast. It's going to spin around really fast, and then they're going to let it go right? And the centrifuge, your merry-go-round, so to speak, spins on in vacuum. It spins in a vacuum chamber, so there's no aerodynamics, right? Then they're gonna let the thing fly. That's what that thing you saw at the beginning was. That's the prototype. They're gonna let it fly. It's gonna shoot out of this thing, and it'll lob it on a high enough trajectory that it would be that the fairing will, it'll fly up, fairing pops off, second stage ignites, and then you get a small sat into space for basically nothing. That's the idea. The idea is that SpinLaunch is prime for making proliferated low Earth orbit constellations. So, like, you could use this to make something like a smaller Starlink or something for next to nothing. That's why they're G-loading these, or they're G-rating these things, because, yeah, here look, I gotta mute the demo music. Look. Here, let's get to the part where stuff that spins. I like things that spin.
Alright, everybody prepare for launch.
Naval countdown.
9, 8, 7, 6, 5, 4, 3, 2, 1, fire.
Pressure is stable. Pressure is stable.
The pressure's good, everything works.
Oh my god, I'm so proud of you guys.
So yeah, that's what they're trying to do. They might have there was a 3D render of this, of what they were trying to do a little while ago. I think it's this one. Yeah, here we go. So watch. So you're telling me this actually works. Well, if you look, guys, see, this video is from 3 years ago. There's two 1U CubeSats right there. See them? They're stacked on top of each other. See, actually, this is a second stage and a third stage. Very simple pressure-fed stuff inside of a missile-shaped fairing.
Listen, Tranquility Base here. The Eagle has landed.
Those are Espa
I know
class.
what we can spin launch next. Cygnus.
No. I gotta be careful about music, dude. So that's your second and third stage, and your fairing right there, right? And watch. Why have it on a turntable? Whatever. So, G-rating the payloads, right? High tensile rotating tether. That's why they're looking to rate satellites to 10,000 Gs because of what's about to happen. Watch. Reliable motors. Yes. This postal launch site. Yeah, watch.
Discovery, go at throttle up.
Come on, TARS! Yeah, we haven't heard anything from them in a long time, dude, but that's just in case people haven't seen that, that's what they're planning on doing. Wouldn't you have to worry about the arm becoming unbalanced after release? This doesn't weigh very much, a negligible amount. Yeah, something like that. Like I said, SpinLaunch is not the it's a little bit of an unorthodox idea, to say the least, but I mean, G-rating your payloads is one step in this process, so it's very clear that there is some viability here. But yeah, very simple upper stages, pressure fed bipropellant. Very, very simple stuff. So I hadn't heard anything from them in years until I saw that video, and I'm like, hey, baby. All right. Well, so it's clear that they're still around, so yeah, there you go. So anyway, yesterday and a little bit of today, NASA Exploration Ground Systems tweeted these photos of them taking the Artemis II core stage and actually bringing it vertical inside of the VAB to put it on its processing stool. The processing stool is built inside of High Bay 2 right here. And it's basically going to be used in the future to assemble core stages. It's going to be used to build these things, to do final assembly for the core stages. They're using core stage 2 to basically finish the rest of the processing that they need to do on the core stage before it's set for stacking for Artemis II. And part of that is making sure that this works. That right there is the last core stage that's going to get rolled in one piece into the VAB. All the core stages from here on out are going to get rolled into the VAB with no main propulsion system attached. The main propulsion system is going to be built down the street from the VAB at the former Space Station Processing Facility, the SSPF. The reason why is because the main propulsion segment of SLS is better engineered inside, or better assembled inside of a clean room. And the SSPF is the biggest clean room that we have. So the back of this is still going to be initially manufactured in Michoud, and then they're going to move it to Florida, complete final assembly of the engine section, and then attach it to the core stage on this processing stool inside of the VAB. Pretty cool. Got to see the core stage vertical, which is pretty awesome. Got a bunch of different pictures right here. Those are space shuttle engines from STS-134 and 135, Cirrus. I don't know which ones. But yeah, there they are, putting the core stage in the new processing cradle that they put that they installed inside of the VAB. And there's a picture of it inside of the cradle. There it is. Was this stage static fired? It was not. Futuramic. They make assembly line equipment and jigs and tools for assembly lines. They're out of Michigan. Pretty cool. You know what would be cooler than one SLS core stage? 2 SLS core stages? Yep. Yep. Agreed. Your neighbor helped build that? All right. No, nice, Archie. Somebody did SpinLaunch in KSP. We've done that before. We tried doing that. It works. It's just really complicated to get it right. 1.5 every year just ain't it. Yep. 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 Hopefully Rook will fix it. Speaking of that, where did it end up? Jared Isaacman made an appearance at the Space Force Association Space Power Conference on Wednesday. Here, it's just a little clip from this. Let's see.
You know, the future of the Polaris program is a little bit a question mark at the moment. It may wind up on hold for a little bit. We'll have to see. But overall, I'm just like super passionate about humankind's future among the stars and what's approaching, because it's going to arrive a lot quicker than probably many of us think. You know, the future. That's cool. So that's Isaacman. That's Jared Isaacman. If you didn't know, he's the nominee for the next NASA administrator. That was in regards to the Polaris program. Might be on hold for. He said it might be on hold for a little bit, which is curious. Article: Your brother-in-law disassembled 40 after the RUD. Yeah, that was a little bit of a mess, huh? Can we get whoever built that to build the ML? This went up real quick. Futuramic, yeah. Could the administrator go into space while in office? I don't see why not. Right? Like... Oh. Rook also had a speech from Embry-Riddle. All right, let's see.
Well, congratulations to the class of 2024. It's an honor to stand here with you today, celebrating not just the accomplishments that have brought you here, but also the journey that lies ahead. You know, a journey into one of the most interesting and really opportune times that aerospace has ever seen. You know, 2 years ago, I was on this stage. I talked about the glory days of aerospace innovation from really the 1950s through the 1980s. You know, the space race that culminated in the Apollo moon landings, you know, to the SR-71 Blackbird, to the Concorde, you know, the early stealth fighters, the space shuttle. I mean, this was a period of really great learning and accomplishments. We were showcasing American ingenuity across the world stage. I also talked about really an unfortunate and recent aerospace drought. And it's a drought that lasted for probably 30 years. I mean, it got so bad that, I mean, America ceded our capability to send astronauts from our own nation for nearly a decade. And when it came to progress in the aviation field, about as wild as things really got was a recycled version of the same aircraft with maybe updated, you know, engines and avionics. It felt like we really lost our edge. You know, we lost our will to push the boundaries. Our tolerance for risk really became near zero, and we got so comfortable, our competitors overseas were able to substantially close capability gaps. You know, but as I stood on this stage, really again 2 years ago, I mentioned there was a reason to be optimistic again. America recently had restored its capability to send astronauts to space from really just down the road at Kennedy Space Center. You know, companies like SpaceX had been catching boosters on ships. You know, Virgin Galactic and Blue Origin had really just begun their suborbital missions. New players like Rocket Lab had emerged as a really reliable orbital launch provider. And overall, you know, rocket reusability was reducing the cost to access orbit. In fact, when I was last up on this stage, I had just come back from leading the first civilian mission to orbit, something previously, you know, unaffordable and really unimaginable. And this was really only the start. That soon there would be a wave of investment in this re-energized aerospace arena full of opportunities and discoveries on the horizon. So now, you know, when we look back, you know, from the last 2 years, how did things shake out? Well, James Webb Telescope went online, which has been just wowing us with incredible views from our solar system to our neighboring galaxies to really views of the oldest part of the universe. I mean, we witnessed a helicopter flying on Mars, you know, sending back incredible footage of where we hope humans will be walking in the not too distant future. Starlink satellites are bringing connectivity to disconnected parts of the world, helping in natural disasters and conflict zones, and soon Kuiper and OneWeb satellites will be capable of doing the same things, which is really so important because access to information is really fundamental to solving so many of the world's problems. You know, pale in comparison to all those, I mean, but 3 months ago, I went to space again on Polaris Dawn with an absolutely incredible crew. We were supported by an army of talented engineers and scientists and technicians, and as was mentioned, we went farther into space since the last time humans walked on the moon, and 2 of my crewmates became the women who've journeyed farthest from this planet ever, which is pretty awesome. We tested the We tested the first new EVA spacesuit in decades during a spacewalk. We tested new laser communications with a global violin performance from space. We even, as mentioned, we put some Embry-Riddle technology to work with the Llamas camera, and we continued our important goal to raise hundreds of millions of dollars for St. Jude Children's Research Hospital and their very important mission. So now, in the short time since we've been back, more history has been made many times over. We witnessed Starship, which is this, skyscraper-sized rocket, fly into space and then come back to Earth to be captured again by the launch tower using chopsticks. I mean, this was a very key milestone in reusability for what will become, an interplanetary spaceship. This turns traditional spacecraft design completely upside down and changes the game with space-based refueling, which is reducing the cost materially while increasing the mass that can be accelerated to orbital and even escape velocities. I mean, this opens up so many new opportunities for experimentation in orbit and putting humankind on a path to exploring and really unlocking the secrets of the universe. Now, the next day after that launch, NASA launched Europa Clipper. And they launched a probe to investigate Jupiter's moon, Europa, on a mission to seek out life on another celestial body. I mean, this is wild stuff, and it's happening right now. There are so many exciting industry-wide projects that are underway, from Blue Origin's New Glenn that really should be launching in the very near future. I mean, and, possibly this month, to Rocket Lab's Neutron, to hypersonics, to direct-to-cell satellites, flying wing refueling tankers, a wave of autonomous, drone technologies, and we're starting to really live in the future that we all dreamed about as kids. So what I'm describing here are all proof points, proof points that we are stepping into a new era, one that demands really the best talent, motivation, perseverance in the face of adversity, and vision for a brighter and more interesting future, the qualities you have undoubtedly begun to develop here at Embry-Riddle. And I want to emphasize that with your education, the opportunities and problems to solve do not necessarily have to be among the stars. I mean, it's about taking the knowledge, the skills, and the drive that have brought you to this point and using them to solve enormous problems for the benefit of all humankind, whether you are on or off Spaceship Earth. Our collective interest in this room, our expertise, our passion for aviation and aerospace provides a profound chance to reshape the way we live, the way we connect, and really understand our world. The industry around us has shown us just a glimpse, and the best is surely left to come. The period of relative aerospace stagnation that I talked about before is over. I mean, we can look ahead to a much brighter future. I mean, there's going to be interplanetary spaceships. Heck, there are going to be factories that are making boosters and spaceships, satellites, probes, robots, lasers, space infrastructure. And this is going to happen as fast as we make airplanes today.
He said
that
the words.
Is the world you are entering today. And I can tell you there are so many problems to solve, so many causes to support, so many great adventures to participate in. So consider this, just as John F. Kennedy challenged a generation to reach to the moon, today you stand at the precipice of your own moonshots. I mean, we're choosing to return to the moon, to create a future on Mars and beyond, and figure out that space economy. We're going to design aircraft that travel faster, cleaner, more efficiently than they ever have, and to foster a sustainable space and aviation ecosystem. And now it's you who will make these possibilities real, working on and off the planet to create technologies that will carry our civilization across the skies, into space, and into the planets beyond. And along the way, who knows? Maybe answer some of the questions that we've all been thinking about since the beginning of humankind. So now, the path ahead, it's not going to be easy. There will be failures, there will be setbacks, and moments when the goals that you all set out to accomplish seem almost unreachable. But those are the very moments that will make you smarter and stronger. You don't get any wiser by having the ball always bounce your way. In aerospace and in aviation, failure isn't a roadblock. It's the foundation of future success story. So take landing and reusing rockets, which was a feat once completely unimaginable, and it began with some pretty spectacular explosions. It's now routine, with hundreds of examples, including one very big one recently. So imagine what this mindset could accomplish in aviation and sustainable energy and in hypersonic and supersonic travel. I mean, these are no longer distant dreams. They're the fields just waiting for pioneers like all of you. So graduates of 2024, you bring what the world needs today. You bring courage, creativity, and passion. Today, you join a legacy of innovators and engineers and scientists and technicians, pilots and astronauts who dared to imagine a future different from the present. But more importantly, you now have the opportunity and the power to be the future that prior generations, they could only watch and dream of in science fiction movies. So class of 2024, go forward, stand tall, let your ambitions be limitless, reach for the stars, and create a better Earth along the way. And Embry-Riddle Eagles, soar higher than you've ever done before. Thank you.
Damn, he's good. Damn. 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 That was a really good speech. Damn. That's hopefully Jeb Willing, your next NASA administrator. That's pretty good. Pretty good. You guys got the goosebumps yet? I got the nerd chills. Definitely. That was pretty good. Wow. Damn. Whoa. All right. I think so, Lunprod. So Squall, he was nominated by the presidential elect. What needs to happen for him to be confirmed? Sorry, I gotta. So he needs to go in front of the Senate. Okay, quick U.S. civics lesson. I've talked about it a lot. I don't want to talk about politics too much. This is civics, not politics. Differences. He needs to go in front of the Senate. The Senate is one of the two Congresses in our legislative branch of the government. So you have an upper house and a lower house. The lower house is representatives. Representatives are representing people. The Senate represents the governments, all 50 states. So the Senate, it has 100 people in it, 2 senators from 50 states. 2 senators from each state. So 100 total. He has to go in front of the Senate, specifically the Commerce, Justice, and Science Committee, and then the Senate has to vote on whether he should be instated as NASA administrator. Judging by that speech, I don't think he's going to have any problems. Joe, but you weren't feeling it kind of uninspiring. Interesting. Dude, well, I can definitely get the point across, man. Thanks for the explanation. Yeah, no problem. Who's better, him or Jeb Kerman? I'll take Jared Isaacman because he exists. I think he'll do good things. And once again, I really don't think he's going to get rid of like SLS or Orion or anything. I'll say it once, I'll say it again, just because we got a lot of news to get through. I really honestly and truly think that he is going to fix those programs and expand them. What NASA needs right now is to get lean, start running, start having that grit and the tenacity that SpaceX has with their own architecture. and then have the commercial market back them up. That's what needs to be done. I think he understands that, and I think he knows that. So we can only hope. Anyway, next news. Aren't there non-voting senators from territories in D.C.? I don't know. Yeah, maybe. It kind of makes sense, I guess. I'm more excited for him than Bill Nelson, that's for sure. Yeah. I don't think so. Anyway. Yeah, exactly. No more putting eating geriatrics at the helm. Hey, Bill, you know, I have my criticisms of Bill, to be honest with you, but he did okay given the circumstances. Hard to do when you're it's hard to just carry the status quo, you know? So they're non-voting House members, but not senators. That's why I got confused and I didn't want to answer the question. No more 2x speed viewing. Dude, can you imagine Rook on 2x speed? Hold on a second. Hold on a second. What does this sound like?
To the SR-71 Blackbird, to the Concorde, you know, the early stealth fighters, the space shuttle. I mean, it's been a period of really great learning and accomplishments. We were showcasing American ingenuity across the world stage. I also talked about really an unfortunate and recent aerospace.
Okay, yep, nope. We don't need to do that no more. If anything, he needs to slow down. Slow down. Oh. Here, let's try 75 speed.
Space drought, and it's a drought that lasted for probably 30 years. I mean, it got so bad that, I mean, America ceded our capability to send astronauts from our own nation for nearly a decade. And when it came to progress in the aviation field, about as wild as things really got was a recycled version of the same aircraft with maybe updated, you know, engines and avionics. It felt like we really lost our edge. You know, we lost our will to push the boundaries. Our tolerance for risk really became near zero, and we got so comfortable.
That part, tolerance for risk becoming near zero, yeah, big deal. Yeah, he's not bad, dude. The guy's a great orator. I really, really hope he does good things. I'm really, really pulling for him. Anyway, next bit of news here. This is coming from Jeff Faust at Space News. In a talk at AGU 24, Rob Lillis says the Escapade mission is now exploring launch opportunities in 2025 and 2026 for the twin small sats, which were to launch in October on the first New Glenn. Those opportunities would set up a Mars arrival in 2027. Yep, looks like they may have missed it by that much. Yeah. Hey, Staveri, what's going on? Yeah, yeah. But New Glenn's, the first New Glenn's mission with the blue ring should be going off sooner rather than later. We'll see. Anyway, next bit. This is coming from ULA, remembering some cool and memorable missions from 2024, including the excitement of 2 Vulcan launches, welcoming ULA to the human spaceflight team with a launch of astronauts top of Atlas V Starliner and bidding a moving farewell to the Delta IV Heavy. Here's to tomorrow's adventures. Okay, little video from ULA.
Go Vulcan. Go Centaur. Go Peregrine.
And liftoff of the first United Launch Alliance Vulcan rocket, launching a new era in spaceflight.
Yeah, baby.
Liftoff of the final United Launch Alliance Delta IV Heavy rocket, closing Delta's 6-decade legacy of excellence in space.
It's not right.
And liftoff of Starliner and Atlas V, carrying 2 American heroes.
We have Starliner separation.
Liftoff of USSF-51 for the United States Space Force on ULA's 100th National Security Mission.
Go Vulcan. Go Centaur. Go CERT-2.
Liftoff of the United Launch Alliance Vulcan rocket, carrying ULA's legacy of reliability, orbital accuracy, and high energy performance.
And very good has been indicated.
Cool. All right. Cool little hype video there. I already missed Delta IV Heavy. Oh, look at that beautiful bastard. Look at that thing. A little bit more news on Slick 37B just in the future. Actually, at the end of this, towards the end of Space News, there's something about this. This pad. See this pad right here? This whole thing? Yeah. All right, Antares. Yeah, that's... Do we know how much small sats there are now? When do you think normal everyday people could start having them launched? We're almost to that point, Trey. We're getting there pretty quick. No water on that one. No sound suppressor. Red Wagon. There's a deluge. There's deluge in the trench though. Yeah. Yeah, a little bit on Slick 37 a little bit later. We'll talk about that in a little bit. Anyway, next thing is coming from Dave Limp. Dave Limp. Another update on the New Glenn launch campaign. Dave Limp. Our sea-based landing platform for New Glenn is one of the largest remotely operated vessels in the world. One cool system on Jacqueline is our recoverable remote... It's an acronym. Damn it. Is our recoverable remotely operated vehicle, or ROV, that connects to New Glenn's reusable boost stage immediately after landing. This connection provides power, communication, and pneumatic links between the booster and the platform. The ROV has a footprint similar to an F-150 truck, but is considerably taller. What sized F-150 truck? Is it a short box? Long box? Quad cab short box? Extended cab? They don't make extended cabs anymore, do they? Standing at around 14 feet tall, that is 4 meters, give or take. When the manipulator arm, standing around 14 feet tall when the manipulator arm is raised, during landing, it's operated from a support vessel 5 to 10 nautical miles away from Jacqueline. What's great about this setup is that it greatly speeds up mission turnaround times and keeps the crew safe. So this thing's a safing vessel. That's what this Pathfinder thing from the NSF flyover is for. It's basically a simulator that's simulating New Glenn with its landing gear deployed. What this thing is really designed to do is go up and interface with the umbilical, which is cool. Yes, they do. They are now called super cabs. Am I the only one that thinks extended cabs are stupid? Crew cab or short cab? No in between. No in between. No. 5 to 10. Pick a format. Hey, Aqualex, I was about to say any unit but the metric system, but I see what you're saying. Do we know how much? Okay, all right, Trey already answered that. Okay, cool. Can I get the link to that speech? Oh, I X'd out of it. Please hold. Yes, here you go. I'll link up the speech, Jared Isaacman's speech in both chats. There you go. Cool. All right, so, once again, from the NSF flyover, this is coming from Alex Alejandro Alquetaria Romera. ¿Dónde está mis zapatos, Alex? All right. Looks like we weren't that far off in the end. We spotted this on our latest flyover at the Cape. Yep, there you go. See, that's that thing, the ROV interfacing with the umbilical. Los zapatos están en la biblioteca? ¿Por qué? Yo necesito. La biblioteca. ¿Por qué? Okay. All right. Anyway, next bit of news. Speaking of Blue Origin. So Austin Barnard posted this. Austin Barnard was he's a kid that started documenting Starship updates in Texas and then eventually got a technician's job at SpaceX. And he actually left SpaceX for Blue Origin because he's going to school in Florida, and he basically walked into a technician's job at Blue Origin while he's going to school for AE and stuff, which is super cool. So he posted these pictures that you guys might appreciate. Austin's good people. Yeah. Just a B4 and then a B3U next to each other. No big deal. Yeah, those are nice. That's New Glenn's first stage and second stage engines, respectively. We don't know why you left them there. There's no say. Porque me gusta la fiesta. Yeah, Austin's good people. That's cool. These are pretty big. These are pretty big. Not the biggest liquid fuel rocket engines ever made. The biggest flown one in terms of expansion ratio and like size, like just straight size, is the F1. The biggest ever made, though not flown, is the M1, which was a Hydrolox vacuum optimized F1. Yeah, fully cryogenic F1. It's called the M1. They never made it. It's supposed to be Nova's second stage engines. Yeah, you want to see? 40-to-1 expansion ratio because frick you. That's not small. Look at the size of that freaking impeller. What the frick, dude? That impeller's like this big. Bro, but EJ, that's too hard to make. It's too hard to make. Listen to what Rook said. No, it's not. NASA's just been gaslit over the last 50 years by people with an axe to grind that they should settle for less. That's bull crap. No, build the M1. Build it better. 3D print it. 3D print it. I don't care. Figure it out. Damn it. No. What about the RD-270 first full flow stage combustion? The 270? It's not that the Russians use they have a bunch of different nozzles for their motors. So I'm not sure if the 270 has that. I don't think it does. But but it's really hard. It makes me have to go poopy. Yeah. 3D printing, you tripping. No. Sorry. It's okay. All right. So, yeah, pretty good stuff. Check this out. Next bit's coming from Astroscale here. Astroscale's ADRASJ achieves historic 15-meter approach to space debris. Astroscale Japan, a subsidiary of Astroscale Holdings Incorporated, Astroscale, the market leader in satellite servicing and long-term orbit... I can't see that text. Let's zoom in. Long-term orbital sustainability across all orbits, has announced that its commercial debris inspection demonstration satellite, active debris removal by Astroscale Japan, ADRAS-J, successfully approached a large piece of space debris, a rocket upper stage, to approximately 15 meters. That's about 50 feet, give or take. This is the closest approach ever achieved by a commercial company to space debris through rendezvous proximity and operations, or RPO. No, not run pass option. That'd be cool in space, but you need spacesuit. Anyway. Artemis was selected by the Japanese Aerospace Exploration Agency for Phase 1 of its commercial removal of debris demonstration. This latest approval, however, was an ambitious goal independently designed by Astroscale, in addition to JAXA's baseline mission requirements. The object was to demonstrate highly precise and complex close-range run-pass option capabilities by advancing to the capture initiation point, where future debris removal missions start robotic capture operations. Or REO, Speedwagon. This is what they want those hentai grippers for. Yeah. Yeah. Okay. Why did you have to call it that? Why did you look at RB? He's all confused. Why did you do this? Extended cab is great for groceries. Come on, you made the joke on Today's News last time. Yeah, but you made it now. But you made it now. I want cake now. I want it now. I want it now. I want cake now. I want it now. How tall would the M1 have been? Probably the size of a 2-story building, Black Eagle. Yeah, pretty big. Got to show them now. I don't have the link no more. When Address J was 50 meters behind the upper stage of the spacecraft, the spacecraft reduced the gap in a straight line approach, then maneuvered to approximately 15 meters below the payload attachment fitting. The planned capture point for the follow-on Address J2 mission, aligning the spacecraft's relative speed, distance, and altitude. Address J successfully maintained this position until an autonomous abort was triggered by the onboard collision avoidance system due to an unexpected relative attitude anomaly with the upper stage. What, something hit it? The spacecraft safely maneuvered away from the debris as designed before reaching the CIP. Astroscale Japan is currently investigating the cause of the abort. Yeah. Dude, I remember looking at these for Space News. Check that out. Huh? That's pretty cool. You currently have a 20-piece McNugget. Delicious. I gotta do, well, Paul, why you gotta make me feel bad? Predominant, the real question is why are you eating McDonald's at like 7 in the morning? That's the real question here. Are you having McNuggets for breakfast? It's almost 9 a.m. Get it right. Question still stands, pal. Yes? You are. Okay, I did too today. I'm not going to lie to you. Yeah, bet you didn't see it going that way, did you? Yep, definitely had chicken McNuggets for breakfast this morning. Oops. I expected an EJ rant. Nope. Yeah, I know. That was the whole point. Yeah, no. Yeah.
Discovery, go at throttle.
No, I didn't have any other food. I went grocery shopping and got nuggets and then had them. What sauce? Maple syrup. What, you don't get that with your nuggies? Don't judge me. Think about it. Dude, it's delicious. I'm telling you. It's delicious. Gross! What? just vomited. Bro, have you guys never had chicken and waffles? It's good. That's like chicken and waffles. It's exactly like chicken and waffles. Try it with honey next time. Man, screw honey. Man, screw your honey. I don't need no honey in here. I can get River to try it and blame you if she loves them. All right, that's fine, Doom. Whatever. I'll take the blame because it's awesome and I'm not apologizing for it. Honey. No. Maple syrup. Anyway, back to space news. Cool. So rendezvous proximity operations are actually super cool because what these address satellites could do is actually start salvaging upper stages, or at least preliminarily, at least to start deorbit these things. What these satellites do is actually get near them, right? And then it said in the article that they want to latch onto the payload attachment fitting. This capability could be very useful. You could deorbit debris. You could grab a pre-existing satellite that's already working, dock to the other side of the payload attachment fitting. You could have a mission extension vehicle. You could use it to refuel satellites if you're working on modularity satellite architecture. If you're working on modular satellite architecture, they could refuel, it could resupply, you could deorbit, you could salvage. It's a pretty awesome capability. Astroscale is working on it with Address, and then Northrop Grumman is working on it with MEVs, mission extension vehicles. Pretty awesome capability. You had me try it. It's all right. I prefer honey, though. Can't win them all. Okay. All right. So let's keep going. Next bit of news is coming from Stoke here. Stoke Space, beautiful hot fire of our Block 2 flight layout engine. Lighting up our new test stand. Incredible team effort. All right. That's the test stand that's up like in Washington, right? Yeah, that's pretty good. Pretty good. Nice. Flame looks a little perturbed right there, but that's okay. So Stoke is working on this engine for their first stage of their Nova rocket, which is a fully reusable 2-stage vehicle. Yeah, pretty good stuff. Next bit is coming from Vast. This has been linked a lot today. You guys really wanted to talk about this. So Vast, let's see, what are they doing? We're putting the final touches on our new test stand in Mojave. This setup is designed to simulate the loads and internal pressures of Haven 1's primary structure will experience during ascent and on-orbit operations. By replicating flight conditions, we'll collect critical strain and deflection data throughout its testing process. Oh, great. It's a big press. It's a big hydraulic press. Welcome to Hydraulic Press Channel. I am Anne and Laura. Hello. Yeah. Doing this with space station modules and fuel tanks and stuff is pretty good. You basically put them in a huge press. This thing will clamp their space station module, which we did share yesterday. Or 2 days ago, I think. They're working on the final, the first welding confidence article. So basically, they're going to take this thing and put it in a gigantic press and squish it and see what happens. Not totally squish it, but somewhat squish it. Hydraulic, yes, that's right, yes. Good stuff, man. Vast is looking to make commercial space stations. And don't get me wrong, there are a lot of people that say they're making commercial space stations, but a lot of other people that say they're making commercial space stations don't have a full pressure vessel like that. Not that that's a bad thing. It's just talk is cheap. Hardware speaks volumes. So this space station is probably not anywhere near launching, obviously. I think it's missing some parts. But having at least getting into fabrication and getting into building something and getting into testing the first article is actually really good. That's really good. The rest of this will fall into place pretty quickly. Also, Billet mentioned very dangerous can attack at any moment, so we must deal with it. Yep. Okay, so I think the rest of everything here is actually, before we get into SpaceX stuff, Boom Supersonic actually gave us another play-by-play from the cockpit of their Flight 7 test. So you guys, here, check this out. This is actually super sick. Is that an E-ray machine? I don't know.
Kessler 1-1, Mojave Tower, roger. We'll line up and wait, runway 30, report when ready.
Okay, Kessler 1-1 flight, line up and wait.
We chose to highlight our 7th flight test because on this mission we made significant gains in Mach number and generated some really interesting testing content that we're excited to share.
Test control, you are go for lineup and a fuel burn of about 400 pounds here.
Copy.
So, what you're looking at right there is the XB1. This is a test article and test demonstrator for a company called Boom Supersonic. What Boom Supersonic is looking to do is make supersonic transports again. Make something that's analogous to Concorde, albeit a little bit smaller, using off-the-shelf components. Part of the reason why Concorde didn't work very well, it worked okay, but part of the reason why it ended up failing was because Concorde was using a lot of military components, like the Olympus engine. They were using military stuff, and that stuff had a lot of high upkeep because it's military stuff. Or military aerospace, let me say. So, it carried a very high cost of operation, considering its engines were designed to be put on a bomber to lift bombs way high up into the air. And those engines, the Olympus engines, made so much power, they just put an afterburner on it and called it a day. They weren't very efficient. But, yeah, one of the reasons why Concorde ended up not working was because it was too expensive to operate. Boom is looking to use more off-the-shelf components to build supersonic transports and bring the cost down. Not necessarily the sound. NASA's working on the sound stuff. But here, check this out.
About 400 pounds.
We're talking about 400 pounds, referring to the fuel burn that we'll need to perform prior to taking off. We overtank XB1 to give us a little bit of extra contingency fuel for pre-flight checks and taxiing out. 400 pounds may sound like a lot, but all we need to do is run the center engine up to afterburner for about 2 minutes and it'll go away.
Oh yeah.
Alright, I'm showing us in band.
Test control concurs. I have you in band. You are go for brake release.
Copy, go for brake release.
I see the bottom screen, dudes. Yeah.
Kessler 1-1 flight.
They're, it looks like their redundant artificial horizon flight display, or just a they have a redundant PFD there. It looks like they sad-faced it out, interestingly enough.
So runway 30, wind 0503, clear for takeoff.
Kessler 1-1 flight, clear for takeoff, 30.
Send it.
Geppetto gave the hand signal that he is about ready to go, and Chase will follow after an 8-second delay. If all goes well, they will rendezvous in the initial right-hand turn right after takeoff. We chose not to execute an airborne pickup on this flight. You can check out the video from Flight 4 if you want to see what one of those look like. But we did this mainly to conserve fuel on the Chase aircraft. Our missions are getting longer and longer, and we don't want to become limited by Chase's fuel state.
3 up and locked.
Yeah.
Clean. Out of burner coming right.
Yeah.
A little choppy in the band by the mountains, but nice and smooth now.
Kessler 1-1, ultra-flight of our 2505 is approved at or above 10,000.
They're using a T-38.
Above 10,000, Kessler 101 flight.
Nice.
Geppetto is pretty stoked here that we got the airspace clearance we wanted, flying over China Lake Naval Air Station. It's a bit northeast of Edwards Air Force Base, and having access to this area will give us a little more room and should help with test point efficiency a bit.
Test control, your go to load says profile 1 and set altimeter to 90902.
We're queuing up the flutter exciter for our first mission test point while we climb to 20,000 feet.
902.
So, if you look at the XB-1, they have little pods on the ends of the wings. It's called an FES, Flutter Excitation System. What those are something analogous to the rumble pack that you'd see on a controller, like a console controller. Like there's little motors in here with a counterweight and it spins and that causes vibrations. What they're trying to do with the Flutter Excitation System is induce flutter on the wings. Flutter with wings is basically when your airplane wings start doing this. Flutter is very bad for airplanes. So what they're doing with the Flutter Excitation System is really trying to figure out they're trying to broaden the scope of the flight regime with this plane to make sure, once they push it past supersonic, it doesn't just rip itself to pieces. Probably a good thing to test for. But yeah, they haven't gone supersonic yet. They've skirted transonic on this flight. Well, actually, I'll just watch. But watch.
Geppetto also sets his altimeter to a setting of 29902, which any pilot can tell you is basically the standard thing to do above 18,000 feet.
Test control, I have card 1 complete. Next up is card 2, 0.7 flutter block.
Copy, card 2.
We've been to 0.65 Mach previously, so the first test point is an acceleration out to 0.7 Mach.
Test is 4-6, good pressure.
Chase is 30.
Alright, I am on condition, ready for Excel.
Man, that plane's a looker, dude. Look at that thing. That is a cool looking plane, man.
Control your go for Excel to 0.7.
Copy, Excel to 0.7.
Geppetto does what we call a quick look right here and lightly samples how the airplane feels at this new top speed.
Alright, response seems predictable.
From there, it's right into a flutter profile.
Test control, your go profile 1.
Copy, profile 1's loaded. Arm button blue, here comes profile 1.
During flutter testing, we introduce an oscillatory force at the wingtips. This is what the Flutter Excitation System, that we call the FES, does.
It's hard to show with the wing starting to do that. They're trying to induce flutter.
Essentially vibrates the entire airplane and allows us to measure the damping ratio for each vibratory mode that the airplane has. If you have ever plucked an open guitar string and then lightly tapped over the 12th fret to hear the tone change, you have done flutter testing. Well, kind of. What you sampled were the primary and second harmonic mode of the string. Measuring the time it takes to ring out and become quiet is analogous to measuring the damping ratio. Each part of an airplane has fundamental modes and harmonics as well. It's just a bit more complicated than the guitar string, and the modes tend to interact with one another too. There can be dozens of these modes in an aircraft structure, and we refer to them with terms like wing first bending, second bending, vertical tail torsion, etc. On the ground, they'll all ring out and get quiet pretty quickly, but now imagine playing your guitar in a wind tunnel. At a certain airspeed, the airflow may resonate with the strings and cause them to continually vibrate. Might make for a pretty great music video, but this is really bad for aircraft structure.
Yeah.
So we measure the damping ratios of all the vibratory modes on the airplane, both at each new airspeed and Mach number. Airspeed because the force pushing against the surface changes with airspeed, and Mach number because as the airplane approaches the speed of sound, the local shock waves make the center of aerodynamic pressure change locations. These factors can all change the damping ratios, and we must ensure that they stay well damped throughout the entire envelope.
Profile's complete.
Test control, I have profile complete. Your go to load profile 2.
Profile 2 selected. Make just a little check turn for TM. And I am on condition. Test is ready.
Control, you are go profile 2.
Copy profile 2. Here it comes.
That first profile was an anti-symmetric vibration where one wingtip goes up at the same moment the other wingtip goes down, and the second profile is symmetric where both wingtips go up and down together. It's a balancing act between spending enough time at each frequency to get enough data and not spending forever doing flutter testing and nothing else. After a few flights of trial and error, we have dialed in a technique where we sweep linearly from 4 Hertz through 70 Hertz over the course of 2 minutes for these profiles. And that has worked out so far. Every airplane will be a little bit different here, and you have to just figure out what works for that airplane and that condition in flight test.
Hey, guys.
Profile's complete.
Test control, we had a dropout right at the end, but we got past the critical frequency. I have card 2 complete. Next up, card 3, pacer check-in, SUHQ block.
Copy, out of turn, chaser cleared pacer. Make this turn about 190 or so.
Next up, we're getting into a flying and handling qualities test block. When we say flying qualities, we are talking about the stability of the airplane. Most simply, if the airplane is trimmed, flying straight and level, but then experiences a disturbance, will the airplane tend to return to that trim state, or will it diverge away from the trim state without any pilot intervention? That is why we're individually upsetting the airplane in each axis, pitch, then yaw, then roll. We carefully measure the response to these inputs and then trend that information as a function of speed with the same maneuvers conducted at other conditions.
Oh boy, functions! No, yeah, I get what they're doing. They're basically making sure that they can trim the plane out and have it keep going straight at high speed.
Control, you are go pitch doublet.
Copy, pitch doublet in 3, 2, 1. Mark. Control's quiet.
Test control, trace is quiet. You are go yaw doublet.
Yaw doublet in 3, 2, 1. Mark. Control's quiet.
Test control, trace is quiet. You are go roll step.
Copy, we'll start to the right and come back to the left.
Watch this.
Whoop. To the left in 3, 2, 1. Mark.
This gives us the information to extrapolate a little bit and estimate what the airplane will fly like at the next highest test speed.
A couple brief roll hesitations like we saw in the sim, but overall, good.
Test control, you are go for HQ block.
I'm happy with HQs. We can continue.
Copy. Test control, you're go to begin climb to 23,000 feet at 0.7.
There's a reason why I share this stuff with you guys. This is super cool. If you really want to understand a little bit, like we talk a lot about rocket testing and what you need to test with rockets, but we don't, it's not every day you get to see a new airplane get tested and have it be very straightforward and upfront. Like, it's really, really cool. Basically what they're doing here, like if you really want a brief summary of what they're doing every flight, they're pushing the plane slightly faster every time, testing that FES every time, right? And basically what they're trying to do is, you know, you go faster and faster and faster and faster. And if you push it in little increments, you could basically create a table that will, like, over time, that'll map out the entire plane's, not maneuverability, but how the entire plane is going to act over, like, through its entire flight regime. This is a really good way to do this. Just push it a little more, and a little more, and a little more, and a little more every time until you get to where you need to. It's basically building a complete table of flight dynamics here with every iterative test. It's really cool. Yeah, exactly, Tessa. They're building its handling characteristics. They're figuring out, they've probably already figured out where it stalls, for instance, right? But this is all really, really super valuable data to figure out where this plane's flight regime really is when they go to build their supersonic transports, they'll know exactly how to build them and exactly where they need to fly and how they need to fly, which is actually super cool. That's what this plane is for.
Copy, climbing at 23.
This is the first time that we have ever been to 23,000 feet, and
awesome.
We're evaluating the environmental control system's ability to keep the cockpit pressurized at this altitude.
Test control, I have card 3 complete. Next up is card 4, ECS pressurization test.
Copy.
20,000 feet.
The compressor in the center engine is the source of pressurized air for the cockpit. So our first test point, we bring the engine to idle and make sure that pressure still holds at that setting.
21,000 feet.
Alright, I am on condition for card 4.
Lead over the Palmdale vortex and resume our navigation.
Center throttle to idle.
Alright, center throttle's coming to idle. Is a bit of a decrease in airflow. Cabin altitude's holding 82.
I got you, David.
Control your go, center throttle down.
Copy, idle RPM 72%, center throttle's coming up. Good response.
In the next test point, we close the valve which supplies air to the cockpit. We expect some pressure leakage here, as evidenced by the altitude within the cockpit climbing slightly.
Test control your go, step 5, airflow switch off.
Copy. Alright, airflow coming off in 3, 2, 1, mark. Alright, airflow stop. Cabin altitude's coming up gradually.
Test control your go, airflow switch on.
Airflow switch.
That's super interesting that they measure the cabin pressure in terms of altitude. I actually didn't know that. That's something I learned. Does every plane do that? I wouldn't know. Jock, does every plane do that? Do they measure cabin pressure in terms of altitude to make it easier to understand? There's also a sad face on their redundant flight display. Yeah. AGL pressure. Oh, okay. Or ASL pressure. Yeah, I gotcha. This plane costs a lot, as much as SLS. I don't think so, no. That sounds like a very easy way to measure. Yeah, with my limited knowledge of engineering, I'd be like, why not just use pressure? But, yeah, no, correlating it to altitude makes sense. What airplane is this? This is Boom Supersonic's XB-1. Elhook Boom is trying to make low-cost supersonic transports. They're trying to build a cheaper Concorde. Yeah, dude, their renders for their plane are really, dude, this plane is a looker. But what you're looking at here is their XB-1. This is their experimental plane. And they're testing out their flight characteristics, avionics, engines. They're testing everything with it. This plane is a looker. It is a beautiful plane. Here, I'll show you. Just gotta shut the door. It's getting kind of cold. Here, check this out. Yeah, dude, you should see what these things look like. It looks... Here, I'll show you. I will show you real quick. Yeah, Boom Supersonic. That's what they're playing. Oh, bruh. This plane that you're seeing fly around is a test article to understand flight characteristics for that. Does it have ramjets? Nope. Kirok, what they're trying to do is use off-the-shelf components. Yeah, unlike, so Concorde and the Tupolev 144, right? Those are using military engines. They have military jets. And the Tu-144 was a piece of junk because they didn't understand flutter, which is funny that they bring that up. But the Concorde, which honestly is... very nice. The Concorde uses Rolls-Royce Olympus engines and SNECMA turbochargers, SNECMA afterburners. It's military tech, so that made maintenance costs very expensive, and that was one of the reasons why they stopped flying Concorde. It was just too expensive to maintain. Boom is trying to use off-the-shelf components and modern manufacturing to bring the costs down. And they're going to be running 3 Honda Civics with spoon engines. Yeah, they're... Oh. Very nice. Anyway, let's get back to their video.
Coming on. Set. Max cabin altitude I saw was 9,800.
The last test point here is similar. It just uses a different valve that we call the bleed air valve, which isolates the air to the cockpit further upstream, closer to the engine.
Test control, your go step 8, bleed air button depressed.
Do it, Joe.
Alright, here comes bleed air button. In 3.
Joe, I'll give you $50 if you do. Also, consider what they were first making, when they were first making pressurized cabins, how it must have been fairly easy just to toss the spare altimeter in the cabin to measure the pressure, as well knowing the environmental effects of various altitudes. Yeah, Aqualex, that makes sense. Makes perfect sense. Cabin altitude...
Oh, this is space. I'm in space.
Cabin altitude is really common. If I recall correctly, I've even heard it by pilots on commercial flights as a passenger. Older airliners are like 8,000 feet, while the A350 and 787 have moved down to 6,000 feet for comfort. Yeah, their flight today was canceled due to weather. They're going to retry tomorrow. That lets them slowly equalize cabin pressure to ground level at the destination airport from departure, so you don't have your ears pop. I hate that, dude. That's so annoying when you fly. For us YouTube folks, what are you giving him money for? David, Joe is he's a photographer, and he lives near the factory where Boom is going to be making that passenger liner. It's in North Carolina. So I said, go take pictures of it so I can use it as a picture. I'll give you $50. It's 15 minutes from me. Let me see if I have any old pics of its construction. I don't. All right, fine. You don't want $50. Find the old pictures then. I'll just use those.
2, 1, mark.
If there are no leaks in the system, we would expect a similar result to the previous test point.
Alright, similar response. Cabin altitude's gradually increasing.
Test control, your go, bleed air button undepressed.
Alright, bleed air button undepressed. Set, airflow resumes.
Dude, this is sick. This is really cool.
Cabin altitude back to 81. Max I saw was 97. Looks good.
Dude, I don't know about you guys, but this is scratching the testing itch. I'm like, I would do this. Do this as my job. That guy though, Geppetto, that's his call sign, Top Gun pilot. So I probably couldn't do that, but you know, still cool.
Having successfully performed this cockpit pressurization test, we've unblocked a self-imposed limitation against climbing above 25,000 feet. This is somewhat arbitrary, but 25,000 feet is typically regarded as the boundary for high-altitude operations, and we want to make sure that there are no issues with the cockpit environmental controls before sending our test pilot up there.
Yeah, that's probably a good idea. Just don't want to have your pilot suffocate. Yeah, you should probably, it's probably a good idea that you tested that. They haven't gone supersonic, Linprod. They're going to soon, though.
Control, your go to descend to 20,000 feet at 0.7 Mach.
Copy, coming back down to 20.
And test control, I have card 4 complete. Next up is card 5, Excel and quick look.
Copy. I'm going to start a left turn. Another 30 degrees of turn. We'll Excel, and then we'll get one more turn before we start the flutter.
Control.
No, Iger, I was quoting a movie.
Alright, ready for Excel.
Test control, your go for Excel to 337 keys.
Copy, 337.
337 indicated knots at 20,000 feet results in an even 325 knots equivalent airspeed. It's also right in the middle of Mach 0.7 and 0.75, so it's a convenient condition to pause for a brief handling qualities assessment.
Test control, your go for Excel to 0.75.
Copy, 0.75.
Yeah, that too, awkward.
As soon as we get to 0.75 Mach, we get right into flutter testing.
Alright, there's 0.75.
Test control, I have card 5 complete. Next up is card 6, 0.75 flutter block. You are go to load profile 1.
Profile 1 selected. Alright, I'm on condition.
Test control, you are go profile 1.
Copy, profile 1. Running.
The flutter tests take the most amount of time to process the data live in the control room for clearance to the next speed, so we do it first.
Profile's complete.
Test control, your go to load profile 2.
Profile 2 selected.
Putting up 1902, level test control, you have go profile 2.
Alright, here comes profile 2.
And flight 1902, Joshua approach the Edwards altimeter 3001.
Alright, profile's complete.
Test control, good sweep, your go pacer.
Chaser, clear pacer. I felt some lateral oscillations on that up to about 30 hertz or so. You guys happy? Okay with that? Alright, 3, 2, 1. Mark 343, 20,010.
350, 25 300.
Copy.
And we do another pacer check here, like we do at each new airspeed, to confirm the air data system is still working well.
Test control, we believe that lateral oscillation was FES-induced. Okay to continue. And I have card 6 complete, next up card 7, your go pitch doublet.
Yeah.
Alright, I'll come out of this turn with a roll step. To the right in 3, 2, 1. Mark. Feels about the same as it did at 0.7.
Listen, Clayton, they'll say what they're testing.
Well, good roll step, your go pitch doublet.
Alright, pitch doublet in 3, 2, 1. Mark. Control's quiet.
Test control, trace is quiet, your go yaw doublet.
Okay, so what they're doing, guys, is they're just getting testing points about how this is what they're doing right there. Particularly is testing their control systems just to make sure they work in certain conditions. The plane actually has oscillators on each tip of the wing that basically gets the wing to vibrate and tries to induce flutter, so they understand basically what to do and what not to do with the airplane. These wings are so ridiculously thin that they're very easy to flutter. Long story short, if an airplane wing starts doing this, you got big problems. That means, because if it's doing that, that means it's not generating lift. Because that means you're getting oscillating pressure over and under the wing, which is bad. Amongst other things, that's really bad for it. But you remember, wings are made out of aluminum. What happens if you move that around real fast? Yeah, you don't want your wing doing that. Yeah. So they're testing the wings to make sure, to figure out where the flutter, they're exciting the wings to figure out in different flight regimes to see if the thing is controllable. I mean, amongst other things. And they're obviously figuring out how you should and shouldn't fly it. But they're going very, very slowly. The idea is that this plane is going to go supersonic eventually. Now, guys, I know, you kind of look at it and you're like, oh, that's kind of cool. But think about that for a second. How many civilian planes out there go supersonic? Well, there's stretching. The wings can bend, Kirok. That's fine. But fluttering is very bad for them. 0. This is a civilian thing, guys. This is a private company. Boom Supersonic is a civilian aerospace company. So just take that for what it's worth.
Alright, yaw doublet in 3, 2, 1. Mark. Control's quiet.
Really bright.
Test control, much less damp. Trace is now quiet, your go for HQ block.
Copy. Lateral stick movements are kind of setting off a little bit of an oscillation.
No, this is important.
I'm okay to continue.
Test control, copy is your go for a decel to 0.65 Mach at 20,000 feet.
Copy, decel to 0.65.
We're now in a hold for about 10 minutes waiting for clearance to be issued from the flutter engineers in the control room before going any faster. So we use this time to collect some data on FES profiles that are only 1 minute in duration at a speed that we have already cleared on a previous flight. The advantage of these profiles is obviously that they're faster than the 2-minute profiles, but they'll come at a consequence of lower data quality. So we're curious if they may still be good enough to clear flutter test points, because it will make for more efficiency in future test flights.
Alright, I'm on condition.
Control, I have card 7 complete. We are on card 8.65 flutter block. Sweep is confirmed. You are go profile 3.
Response and roll. But I'm on condition, ready for profile 1.
Test control, your go profile 1.
Copy, here comes profile 1. Alright, profile's complete.
Test control, your go to load profile 2.
Copy, what I'd like to do is the flying qualities block here, and then that way we'll run the profile 2 pointed back toward Mojave.
That sounds good. Test control, I've got you on card 10, and you are go for a pitch doublet.
Copy, I'm going to start a little turn here to flow about 350.
The pilot and the TC are negotiating a little bit here for a test point priority, given the constraints of airspace management. It's less important to do the flutter first this time because this is the fastest test point we have planned for the flight, and so there will be no need for an in-flight flutter clearance, and we'll just look at the data on the ground.
Alright, pitch doublet in 3, 2, 1, mark. Controls quiet.
Test control, trace is quiet. You are go yaw doublet. Reminder to be very careful on this, it's not well damped.
You got it. Alright, yaw doublet in 3, 2, 1, mark. Controls quiet.
Test control, trace is quiet. You are go roll step.
Copy, we'll start to the right and then come back to the left.
So,
we learned a lot about the stability augmentation system on this flight. Subsequently, we have tweaked the gains to make things a little bit smoother at this Mach number.
Alright, a little ratchety again, pretty similar to what we saw in the sim yesterday.
Test control, you go for HT block.
Copy, we'll get it in the turn here.
Handling qualities testing gathers data on the human-machine interface. It's different than flying qualities testing. What we're doing here is gathering data on how easy it is and to what level of precision a human pilot can perform a specific task in the airplane. The classic way to do this is for the pilot to issue a Cooper-Harper rating for the given conditions and task, with a 1 being the best possible rating, low effort, very easy, and 10 meaning that it's completely impossible. In the specific case here, because this is the first time this airplane design has ever seen this Mach number, we're evaluating the handling qualities of a very basic task, simply maintaining a constant airspeed through straight and level flight, as well as gentle turns for airspace.
Not just engines and wings, Kirok, it's testing their avionics.
Alright, handling qualities appear adequate. It actually feels a little bit better at 0.8 than it did at 0.75.
Everything.
Control copies.
personal hobby down there. Really good.
Alright, I am on condition profile 2 selected.
Test control, your go profile 2.
Alright, here comes profile 2.
Monkas.
Alright, profile's complete.
And for this last test point, we're getting into testing the basic airplane with the stability augmentation systems turned off. And we're doing this to make sure that the unaugmented airplane is still safe to fly in the event that the systems were to fault as we continue to go faster.
They turned SAS off!
Test control, I have card 9 complete. Next up is card 11, damper off.
Do you want to see NASA get an overture in the future?
I mean, I'm sure it'd be useful.
HQs.
Copy, I'm ready for pitch damper off.
Test control, your go pitch damper off.
Alright, pitch damper's coming in 3, 2, 1. Mark.
On XB1, the augmentation is not required for safe operation. It just makes everything feel a bit better. This is different than, say, a military fighter jet, where it might be impossible to fly if the stability augmentation were to fail.
F-16.
Not relying on digital stability control augmentation for a safe flying airplane was one of the major reasons why XB1 was such a challenge to design, and why it feels so rewarding to have succeeded in this effort.
So basically, they have an augmented system where they're using the computers to help you fly the plane, but they also made it so you could shut that off and fly the plane. So it's good straight, like, you don't need a computer to necessarily augment your flight inputs, which is actually, that's super, guy ain't kidding, that's not easy to do. Like an F-16, if it didn't have its flight computer, it would fall out of the sky. It would basically nosedive and crash, along with most modern fighter planes. There's not many of them that are just relied to just be straight, like, good aerodynamics. Like, that's crazy, dude. Yeah, maybe, Tessa, yeah. It's the same as Airbus. Normal law, degraded law, direct law, computer coupling between stick and control surfaces. Yep, yeah.
Alright, pitch is a bit springy, but it still seems pretty well damped.
That's cool.
Control copies, your go pitch damper on.
Copy 13275, chase. Pitch damper's coming on.
It's time I address the elephant in the room. You may be noticing that there's a frowny face on the instrument panel. That little screen there started to display an incorrect artificial horizon on the last flight, which can be very distracting and unsafe. We don't need that instrument because we already have a primary and a backup on that screen to the left, but we also use that lower center instrument as a backup source of airspeed indication, and it's the only one. We're working with a vendor on a fix here, but until that is ready, we just taped over the artificial horizon part, leaving the airspeed indicator visible. The maintenance team has expressed their emotions about this particular component's durability via a silver Sharpie marker.
Test control reminder to reset altimeter.
Thank you. That answers that question.
Test control, we're going to look for 167 on approach.
Copy.
167 knots. She is referring to the recommended approach speed for landing, which we update every time based on how heavy we are from our fuel state.
Kestrel, standby gear.
Yeah, what are you saying? Most aircraft are not statically unstable. They are dynamically unstable. A lot of tactical fighters, etc., to get more performance. Yeah, exactly. So they basically, without the computer, when you're maneuvering around, it could get a little bit hard to control if you don't have an assist. Yep. That's cool. If you leave it alone, it won't depart, basically, but that is hard to do when you try to fly it. That's pretty impressive that they were able to, they have a detachable, they can shut SAS off, to speak in Kerbal terms. Didn't a B-2 crash because there was a problem with one air sensor and the flight computer went completely crazy? Sounds right. Yeah, that sounds right, but I don't remember.
3, 2, 1, mark.
You're coming. You're down.
Alright, 3 down to log. Dampers on, flight controls auto, anti-skids auto, 165.
Yes, paddle contact, winds are calm.
Test 1.5.
You're live, you're on Sterling.
Our landing signal officer on this flight is Charles Wigware, call sign Wingnut.
That's an awesome call sign. Wingnut. Hell yeah.
You're on glide path, 50 feet. You're on Sterling. 40 feet.
30.
30 feet.
20.
20.
10.
10.
5.
5.
Another perfect landing by Geppetto. Thanks for watching. We really appreciate the interest and stay tuned. There are only a few more test flights left before we break the sound barrier in the world's first independently developed, human-rated, supersonic airplane.
That's badass, man. That's really cool. See that high angle of attack? Yeah, during landing, you need to. Long story short, the plane has small wings. But it's a little more than that, isn't it? It's a little more than that, huh? Look at the wings. See how the leading edge of the wing is curved? It's curved like it has like an armpit almost, right? That's necessary. You need a high angle of attack to make that type of wing. That small, little, tiny freaking wing can generate enough lift to lift that to basically have that whole plane glide in for a landing. Look at how small that wing is, right? Pretty crazy. That makes that whole fuselage, you know, you can basically glide the plane, right? It's because of that armpit in the front of the wing. What that's doing is basically allowing air in a certain part of the wing to vortex over the top of the wing, generating a lot of low pressure on the top side of this. You have low pressure, a vortex getting created over the top of the wing, creates super low pressure on top, and then because you're at a high angle of attack, you get a lot of high pressure at the bottom of the wing. Once again, that little armpit, that straight delta wing right there, like what the Space Shuttle or Concorde or the Tu-144 has, right? That is, that's what's required to get a wing that can fly up there, theoretically going supersonic, but also be enough wing to have you land. Pretty cool, huh? There's a man on the wing. Yeah, look at how small that wing is comparatively to the rest of the plane. Pretty cool, huh? Yeah, that little armpit at the front of the wing is what's making that whole thing work. If that was just a straight edge, this thing would fall out of the sky. Weird, huh? Space Shuttle does the same thing. That was the only way they could get that 62-ton brick to actually glide, even if it was only for like a couple seconds. That's all you needed to land it. Concorde, as everybody recalls, had the nose that actually droops down. So the pilot could see the freaking runway because you had to land at a super high angle of attack to get that thing to fly. Who is the intended customer for this? Airliners. Airline operators, Knight. The snoot. It droops. But yeah, that was XB7. I will keep showing these videos during Space News as they come in. So, let's move over. Speaking of weird wing shapes. Hey, Wrecker, 17 months. This is a little bit, this is from yesterday, but this is coming from LSR, who's captured NSF, the NSF live camera, Starbase Live. Check that out. Ship 33. This is a little bit of yesterday's space news. Ship 33 was moved out of the build site. Yowza. It was moved out of the build site. Down on the head crab right there, down to Massey's for testing. Note that this is the first flight of kind of a big block change for Starship. Note the front wings are a little different. I mean, amongst other things. It also has way more fuel tankage and a little bit of a smaller payload bay. It's at a new stand. That's the stand that they use for static firing Starships, King. It's been around for a little while. Probably like a year. Bam, 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 bam. Bam, 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 bam. Ba 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 bum. Ba 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 bum. Ba 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 bum. Hit the frick ups. Ba 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 bum. Sorry, it just reminds me of that every time. I'm just taking my rocket for a walk. Yep, there's another shot of it coming from Starbase Live. See, note that this has a way bigger methane tank and a way bigger LOX tank. It has a much smaller payload volume. Interesting that they went this way. That's probably the reason why they eventually want to extend Starship's design. But yeah, there you go. Dude, freaking beast. The thing about Ship 33, though, look, they actually started covering up a lot of things. A lot of the components on the top are covered up. Where will the bananas go? They go up. But that's not important right now. Yeah, definitely nice. Definitely nice. Yeah. And look, the tiles, the tiles on Ship 31 or Ship 30 were like up here somewhere. Those tiles are actually, no, that's probably an illusion because of the flaps. Ship 31s were down here somewhere. Still cool. Nearly double the propellant load of V1 due to having 6 RVACs. Oh. Nice. Does this one have 6 vacuum on it, entropy? Wait, did they did that? Face the bananas, please. Where are the catch pins? Not there yet. Yeah, RC, I was gonna say I don't think they did that to this one yet. This one only has, this is the 6-engine configuration. Sorry, that was for V3. Got it. Cool. So yeah, that's what's going on. Just want to make sure that we okay. So Ship 33 is down at Massey's, and check this out. This is coming from Harry Stranger. A meeting agenda from Space Florida mentions a new project named Hinton, which involves a high-volume production facility, high bay, and related infrastructure. This could be a perfect fit for what SpaceX is planning at the Roberts Road Northern Expansion Site. It also mentions the project will enable rapid manufacturing, assembly, and integration of heavy-lift flight hardware. Interesting. Project anticipates an investment of approximately $1.8 billion in capital improvements and will create 600 jobs with an estimated average annual wage of $93,000. $93,000. Project is in alignment with the Cape Canaveral Spaceport Master Plan and Florida Spaceport Systems goals. Yeah, they're building a $1.8 billion freaking factory up in there. You'll ask your neighbor about it, article? All right. Cool. Oh, Starship Gazer. This is going back over to Boca Chica real quick. Starship Gazer got some, yep. There's your pad delusion flame bucket, at least the start of it right there. See it? See the holes? You can tell it's a flame bucket because of the way it is. There's going to be a bunch of pipes all attached to this thing, and they're going to be in the shape of a flame deflector. put the deluge system into the flame deflector, which is what we think is going to go in SpaceX Pad B. We think. It looks like steel to me, Steve Kraken, but yeah. Okay, cool. Dina Arevalo. Today, SpaceX filed a petition with Cameron County Judge Trevino asking for special election to decide if Starbase can incorporate as a municipality. To continue growing the workforce necessary to manufacture Starship, we need the ability to grow SpaceX as a community. They're going to try to incorporate it. Okay. Okay. I guess that makes sense. Does that mean there's going to be a post office down there or what? All right, what's this? Looks like UT Rio Grande Valley has been authorized to sell the Stargate building to SpaceX. Oh, safe to assume this building won't survive too long after everything is finalized. The next phase of SpaceX development is right around the corner. Okay. Mayor of SpaceX community. Oh gosh. Got some autonomy over the land. Yeah, RC, that makes sense. Gigabay time. So, here, let me show you guys what we're talking about. So if we zoom into Starbase, right? One of the first buildings out here was the building that just got sold to SpaceX. Stargate building. That's that one right there. That was one of the first buildings out here. If you go back to in the timeline, right? Take a look. See? That was one of the first things made. That building was there for universities because they built it back in the day when SpaceX was looking to launch Falcon 9s from here. You could see that's the start of a Falcon 9 HIF, and they were going to have a crawl away out to a launch pad basically right here and be able to launch Falcon Heavy and Falcon 9 from here. Those plans eventually fell through, and well, you know how that ended from there. So UT Rio Grande Valley, University of Texas Rio Grande Valley has owned Stargate since then. Since 2017, it's gotten a little crowded. It's gotten a little crowded around that building. Once again, all signs are pointing to SpaceX basically building a gigantic high bay for Starship manufacture right here. We did theorize about it a little bit. I honestly think there's just going to be, if you took this high bay and you extruded it this way, or basically built a high bay in this area right here, I'm pretty sure that this is what this is going to end up looking like. Like maybe something like this. They're going to build a gigantic high bay. Something that's as tall as these buildings here. All the way to the front. And this is basically going to be a production line. They'll start with like Starship engine sections here. Right? Stack it and then move it this way. And see how the buildings are kind of built in rows? Each one of those is a production line. And they're going to basically just turn this into an assembly line right here. Probably one, if I had to guess, probably two. Two assembly lines, probably one for Starship, one for Super Heavy, and then just roll them out. Would that be the largest building by volume? That definitely would be up there, Trey. That's almost as big as the VAB. It's not nearly as tall, though. The VAB is twice as tall as these buildings. VAB is huge, man. High bay, like a highway. They're satisfactory completionists. Yep. Mm-hmm. I'm telling you, man, you know, the more I look at this, the more, look, these buildings are built in rows. And we know because they put windows right here that SpaceX is basically, they basically start over here, right? Like, and then it goes down, they move laterally down these. Like people have stood here and filmed and watched the nose cones get moved down the assembly line. Right? So And we know that the nose cones are at this in this front building right here. They're going this way. This is a factory. These are each assembly lines for all of Starship's different components. One of them is just making rings. Another one is making engine segments for Starship. Another one's making engine segments for Super Heavy. Another one is making common bulkheads. Another one of these lines is making nose cones. Another one is making payload bays. And they're just gonna stack it, and then just Starships will just roll out of a door right here. At least that's what I think. I'm pretty sure that's what's going on. So SpaceX just bought that building right there from University of Texas, Rio Grande Valley. They bought Stargate, which is this one right here. That originally was their mission control back in the day, and then they moved mission control to the top of one of these, right? So I think Zach is probably right. There's probably going to be a gigantic high bay right here. It's probably going to be double wide this and then this way. See what I mean? The only thing that's kind of throwing me off is the diagonal right here. It's a little strange, but another making payloads, another making high bays. Yep. The only thing that's missing is a rail yard, really. Yeah, right? It's crazy that such a massive industrial center is serviced by one relatively small road. You're going to... Yeah, I mean... It's interesting that you know, somebody over there, Ilowin, it's interesting you mentioned that, and Sirit, it's interesting you mentioned that, dude. Build a highway and build a train track out here. Bring in the rolls of steel by train, dude. It's not a bad idea. What is your opinion that NASA wastes its budget and the program advances much slower than, for example, SpaceX? NASA brings a lot more to the table than just, you know, launching stuff. Iñaki, that they bring a lot more to the table, like, you know, building the science missions and using rockets that aren't necessarily for a commercial market. Like SLS has no commercial market. That's because there's no market in sending people to the moon. Not yet, at least. If we launched it more, maybe NASA could build the market to get to the moon. But it doesn't necessarily need a high launch cadence. Though NASA should be pioneering technologies, and there's no reason why they can't go slow. The reason why they go slow is because they have no direction. It's not necessarily the cost. I think the money is there, and I think the money is pretty decently well spent on the technology. We just got to launch. We just got to do it more. We're going to build this $4 billion rocket and then launch it once a year? That's gross. Launch it 4 times a year. Or 12. Screw it. Launching the damn thing is the easy part. Building the stupid factory for it and getting all the components and industrial supply lines set up to build to make said rocket, that's the hard part. That's what costs so much money. I'm hoping that the incoming administration will make NASA actually do stuff quickly for a change. But we'll see. I believe that both need to exist because the post office does something that FedEx doesn't, right? But FedEx can move stuff a lot quicker than the post office can now, can't they? Just something to consider. And at the end of the day, launch services are a logistical service. They're a form of transportation, just like any other one. Lost leader for technology. It's vital. When is the city going to start building up around here? Midget, looks like they're playing cities right there, huh? NASA quickly, isn't that an oxymoron? Well, you've been conditioned to think that it is, Tessa. They didn't go slow in the 60s. Arguably, they didn't go slow in the 70s either, even with the space shuttle and no budget. How about we get back to doing that? How about, you know, get back to doing that? It's probably a good idea. Anyway, that's cool. Now, we are actually going to move over to Cape Canaveral. Send Google Earth over there and check this out, dudes. So, there was an e-permit filing from the St. George River Water Management District. These are the pictures here. Those are small. Let's get this. Ready? So check this out. They're working on a project site right here. Now, if you notice, right there is slightly north of 39A. what is this for? Let's check the application here. Petition for a formal determination of landward extent of wetlands and outer surface waters. This form constitutes a petition to the agency for a formal determination of the extent of wetlands and other surface waters in accordance with the Submit this form within the requested copy supporting information. So what does this all say in plain English? SpaceX is expanding 39A for some reason. I'm going to go out on a limb and guess that it's landing pads. Does this mean your Starship theory is out the window? Sure looks that way. Which begs the question, though. That begs the question here. So, if SpaceX wants to build landing pads for Falcon 9 over here as an extension off of 39A, if that's what they want to do, and we know they're disassembling all of the Starship paraphernalia over here, where do Starship pads go down the Cape? So I had a theory that that SpaceX was going to move all Falcon operations off of 39A. It's very clear that if this is indeed landing pads for Falcon 9, that's not happening. So where are they going to go? Well, we watched a ULA compilation video, and we watched the last launch, the L-70 launch from Slick 37. Right here. Call me crazy, but if those are indeed landing pads at 39A, that means Starship is right here. That means I think they're going to move Starship here. And if they move Starship here, I think we're going to see 2 catch towers back to back. Yeah, there, I said it. I don't think that what you suggested will happen in the near term, as it would completely halt production. Probably won't happen before Roberts Road is online. I didn't say anything about that happening in the near term, but yeah, you're probably right. It's always 39C. No. Article 5, 39C is dumb. It was always dumb. It was always an extremely stupid idea, and I hate it. A freaking parking lot on the outskirts of your freaking pad that you just made to look like a launch pad is not an excuse to say you have another launch pad for Complex 39. All that is dumb. NASA built an entire launch facility on the outskirts of 39B in the hope that somebody would want it. And they would hope that somebody would want it and have to share a facility with them to launch their pad when the Air Force at the time has hundreds of pads down here to lease out, and you get priority use of the pad that you lease. That was a dumb idea then. That was a dumb idea now. It's going to be a dumb idea in the future. Do not call that 39C. That's stupid. You want 39C, build another one of these up there. Boom. I said it. I feel very strongly about this. I don't know if you guys realized. We need the real 39C. Bingo. Exactly. No. True 39C, like A and B. Yes. There needs to be, they should build another one of those. Yes, I agree. You do? Yeah. Yeah, well, you're dumb. Yeah, well, RB, I can't hear you. You know why I can't hear you? Because you're timed out. Oh, man. That's strange. Yeah, personally, I didn't, like, the other thing is that personally, I really don't like that NASA pawned off 39A to SpaceX, to be 100% real with you. It's not that I don't like SpaceX. I'm happy they're putting 39A to use. But honestly, that's very unique capability for the type of rocket that you're building. And I really don't like the entire Artemis program basically leaning on one launch complex. I think that is an extraordinarily dumb idea. But, you know. NASA, for whatever reason, had this really great idea of trying to sell as much of their Apollo and shuttle stuff to commercial users as a way to offset costs to try and compete with the Air Force. When in Space Force now. The funny thing is that they were like, oh yeah, well you know we have pads too. We have pads that you can use. They saw the Air Force leasing stuff to contractors, right? All the pads on Missile Row, and they're like, hey, we have that too, and they ended up just leasing the pad to SpaceX. And don't get me wrong, that's cool. I dig it. I'm happy that 39A is being used, but honestly, this needs to be launching something bigger. Yeah, RC, don't worry about RB. Don't listen to him. He's just RB. Just tell him to shut up. That's the meta around here. Shut up, RB. Anyway. They should not. That would remove part of the nature preserve. Dude. There's enough nature preserve. Okay? There's enough nature preserve. All right, one more pad isn't going to hurt. Anyway. So, yeah, SpaceX has some filings in papers to build something north of 39A. And, yeah, like I said, I think it's heavily implied that those are landing zones for Falcon 9. Maybe Aqualux, I don't know. I don't know if they do that, dude. I'm not really noticing much commonality between Falcon 9 and Starship, but who knows? Who knows? Stranger things have happened. We had a launch off of LC-46. Cool. Yep. That was the thing. Joke's on you. I can't read. All right, dudes. NASA needs to expand its pad infrastructure. We're running out of pads for bigger rockets. Agreed. Agreed. They never should have given 39A to SpaceX. But also, I'm not mad that they did either. But if you're insisting on using a crawler transport rocket mobile launcher architecture utilizing the VAB, probably would have been a good idea to retain that and not just have one pad, but just putting it out there. SpaceX building landing zones makes sense, given that in a few years their lease on Launch Complex 13, LZ-1 and 2, runs out. Yep. Yeah, the LC-13 is going to be leased to Varda, I think. They are leasing it, Nova, yep. Mm-hmm. Could they split 39B and make 2 SLS-sized pads on it? Just build 39C. Just build the real 39C. As God intended. Or Jeb. As Jeb intended. Anyway. All right, guys. We got through, actually, all the space news there. That was pretty good. Where's New Glenn launching from? LC-36, Midge. It's like on the very, very tip of Cape Canaveral. As Werner intended. We have been given the scientific knowledge, the technical ability, and the materials to pursue the exploration of the universe. To ignore these great resources would be a corruption of a God-given ability. Jeb-given ability. All right, so that's going to do it for Space News, for the Space and Rocket Review for 12/12/24. I am EJ, your host, I think. And if you... Oh, wait a minute. We have a last-minute cameo. Oh, hello. Oh, wait, what are you doing? What are you doing? What? They're bringing the ball. What are you doing? What are you doing, Poppers? Titan decided he wanted to join in at the end of Space News. Hi, Titan.
Ball and ball review.
Is it chewy enough? You sure? Yeah, it's great. Yeah, it's delicious.
I'll enjoy review.
You have some crickets in the background. It's Starbase Live, Wazzy. I have Starbase Live running so it doesn't idle the sound on the headset. What are you doing?
Chad, I want you to know that EJ has properly sized Titan emotes and has had them for a month. Thank you, geek.
Hey, hey.
I was waiting for it to spin you so I could say you played yourself. It didn't really work. Titan! There are properly sized Titan emotes that he has not uploaded, Chad.
Hi, Bubble. Hello. Give me the ball. Give me the ball. Hey, give me the ball. Thank you. Oh, give me a paw. Paw. Oh, you boy. That's my bundle. Hello, bundle. No. It's just about the ball. Give emote now. Okay. All right. All right. Will do. Hey, bud. Hey, bud. What were you up to?
For a walk, I'm feeling better, so I thought I'd come.
Yeah. All right. Good. Good, good, good. Sweet.
Still a little like, oh my god, but
Yeah.
I took a couple hours and watched Queer Eye, and now everything's better.
That sounds awful.
What?
That sounds awful.
Whatever.
No, I'm glad you're feeling better. Holidays.
Yeah.
Will we see Titan at Starbase?
Probably not.
Probably not, yep.
Fluffy Cattle Snuggles Adorball.
When reindeer antlers and red nose for Titan? Like all the other Titans in Satisfactory. I don't know. Here, Titan, come on.
Wait, those Satisfactory Titans have reindeer antlers? That's pretty fucking cute.
Watch your language, lady.
Sorry. That's pretty stinking cute.
What the bear? What the bear? What's the bear? Hello. Boink.
Yeah, you can get this dog to do anything for a ball.
Yep. This is his favorite. This one is his favorite toy because it looks like. Titan! Titan! Help me! Titan! You need to help me! Titan! Help me! There you go, bud.
When we were at my folks' house, he got lost in the woods, and we had to take the leash off, but it was okay because EJ had a ball, so he just followed EJ.
Yep. Definitely seems happier than when you first got him. Yeah, he's... Everybody said it takes about 6 months with a rescue. That's about right. Yep.
Oh yeah, geek, those are dead. I mean, well, there's still, all of them are out. He's not a big fluffy toy dog. I can't even really get him to use chew toys. He just he just wants ball.
Okay. Dog has hyper focus. You see that? He's like, yeah. Down here, ball is a way of life.
Am I staying here until I watch you upload those emails?
No.
Okay.
No, I'll take care of it.
Alright.
Just got to point me in the direction of where they are or relink
Geek
them.
sent them to you.
Okay, I'll find them. Pretty solid target lock, yeah. It's a good tracking system. What are you doing, buddy? All right, here. Come on. All right. That's going to do it for Space News, guys. You guys know the drill. We're going to jog the VOD. And we will be back for Hearts of Iron here momentarily. There you go. All right, guys. I'll see you guys tomorrow. We won't do space news, but we got Flame Trench tomorrow, so it should be good. Yep, should be a good time. All right.
Titan! You want to leave? I think Daddy wants us to leave. I don't think he wants you to hang out in the chair anymore. I think he's a mean jerk who hates you.
Bye.
Bye, I love you.
Love you too. All right, so I'm going to jog the VOD here on the YouTube side of things. On the Twitch side of things, stay tuned. We got Hearts of Iron. We have our maximalist US isolationist playthrough thing that we're going to finish, well, not finish up, we're going to keep going with. So I'll see you guys in a couple minutes. I'll be right back. Don't go anywhere.